Welcome to the lecture series on data analytics using R. We are going to discuss the visualization part today. Myself, D.Jyothi, Assistant Professor, Department of CSE Data Science, MLR Institute of Technology, Hyderabad. Today we are going to cover these topics: quantile plot, box and whisker plot, bubble chart, image plot, mosaic plot, violin. For the quantile plot, when you have more than 100 data points, you have to go for the quantile plot. So here we are generating the first statement we are using here to generate the 100 data points with a mean equal to 50 and the standard deviation equal to 10. QQ norm and QQ line, these are the two parameters used for the quantile plot. QQ line means it indicates how these values are corresponding to the line it will display. Once you go to the visualization, you will be able to understand. So for the QQ line, we are assigning the red color to the QQ line, and the QQ norm we are assigning the name, we are naming it as QQ plot example. Now look at this one, the visualization. So here, this is the red line. It is displaying. This is the QQ line. For the QQ line, we have assigned the color red. So it is displaying. It is displayed in the red color. When you have to go for this one is like, so I want to identify how many people having the age equal to 50 are diabetic. I want to visualize based in the 100 data points. Then a line will be drawn. It is something like my age limit. I have taken it as 50. So here, so these are the people. These are the people coming into the diabetic. These are the people having the diabetic, and the people means below the line. Here you have some people below the line, and here you have some people above the line. So like this, we put a condition and we analyze. In this case, in this condition, it is something like age 50 and having the diabetic, and these people having the diabetic, and these people are not having the diabetic. So I can categorize. In these situations, we have to use a QQ plot. So customizing a QQ plot. So we will be having the two functions, inbuilt functions, QQ norm and QQ line, and you are taking the epoch value equal to 90 and you are assigning a color equal to blue. And for the QQ line, you are taking the line width as 2, line type is 2 here. So because we have taken the line type is 2, so you will be getting a dashed line like this, and the color applied is red. And for the QQ norm, we have taken the blue color. So look at here, just observe the difference between the first one and the second one. So first one, we don't have the colors assigned to the QQ norm here, so no color is displayed. Whether here, look at here, we have assigned the blue color. In this, we have applied a blue color here. So in the visualization, it will display blue color. Next visualization we are going to discuss is box and whisker plot. The box and whisker plot need to have the more than 100 data point. Then only it is preferable to go to the box and whisker plot. We are generating the random numbers. We are generating the random numbers for the box and whisker plot here. So that is the reason we are setting the seed here. Set that seed 1, 2, 3 for generating the random values. And we are creating a data frame. Here we are creating for the values ABC. We are repeating this ABC. We are using the repetition, and each we are repeating for 20 times. And the values for generating the corresponding values, we are using the rnorm function. Rnorm function is written in a C function. So here it will be generating 20 random numbers with the mean equal to 50 and the standard deviation equal to 10. And look at here, we are also generating 20 numbers. Observe the difference here. The mean value got changed here. Here, for the first one, the mean value is 50. For the second one, the mean value is 60. And the standard deviation is same here. And for the third one, we are again generating the 20 values with the mean is 50 and the standard deviation is 10. So we have generated 3 different sets of data. We have the exact difference in the data we have generated. For the first set, we have the mean 50 and the standard deviation is 10. For the second set, we have the mean 60 and the standard deviation is 10. For the third set, we have the mean 70 and the standard deviation is 10. And this syntax is for drawing a box plot, and we are assigning the name to the box plot like this, box plot example. And X label we have group and the Y label we have the values. Now look at here, when we have generated the data, mean 50 and the standard deviation is 10, but we have the same set of values, 20 values, and the third one also we have generated the 20 values. So we don't have any difference in the box size, only we have the difference in the mean 50 and 60 and 70. So observe the difference. So these will be correlating to the 50, and this is correlating to the 60, and this is correlating to the 70. 50, 60, and this is correlating to the 70, because we have the mean value change. Customizing a box plot. So here we have assigned the data and we have given the name to this one by using the main parameter. We have defined the X label, we have defined the Y label. The color we are applying light blue, light green and light pink colors we are applying. The border we have applying dark blue, and the notch we are setting it to true. Look at the values. There is no difference in the data points. So the same diagram with the different colors applied. Next visualization we are going to discuss is the bubble chart. For the bubble chart, we are generating the values x vector and the y vector. We are assigning the values into x vector and the y vector. And for the size, we have taken a different vector, and for the labels, we have taken different vector. In the plot, we are assigning the x vector and the y vector. We are taking the type as n, and we are assigning the name to the main function as simple bubble chart example. We are assigning x label name, y label name. Here, the symbols we are selecting, we are selecting the circles as the symbols we are selecting, and we are selecting the size 0.5, and the background color blue and the foreground color is black. The text size we are selecting is POS value 4 and CX value 0.8 we are selecting. Now observe so here within the bubble we have a name, B name got displayed. Within the bubble C, within the bubble here we have the E, and here we have D, and here we have the A. So like this the bubble chart will be displayed. Next visualization we are going to discuss is the image plot. For the image plot, we are generating the random numbers starting from 1 to 25. The rows we have selected are 5 and the columns are not selected here. So we are selecting by row equal to true means row wise the values will be assigned. For converting these matrix into image, we are using the image function. In the image function, we are sending the matrix data, and we have selected the name for this plot is basic image plot example. We are assigning the X label and Y label. Now look at the plot here. So this entire matrix got converted into an image, x-axis and the y-axis. Customizing an image plot, only the difference is we are taking the colors. We are taking the colors terrain dot colors is added here. We are assigning the 25 different colors, and look at the image here. 25 different colors got applied to the previous matrix. Next plot we are going to discuss is the mosaic plot. Mosaic plot need to be used when you have the more than 100 data points. We are generating the values randomly here. So here, look at here, for setting the seed, we are using set.seed, and in the gender, we are generating 100 data points with the values male and female. 100 data points with the attributes smoker and non-smoker. These data is got converted into a data frame. We are assigning the attributes here. These attributes are assigned to a data frame. These data frame data is assigned to the data here. Now you are creating a mosaic plot with the data we have created, the data frame we have created. The name we have assigned is mosaic plot. The color we are assigning is, we are setting high value, one value for the color. So look at here, the mosaic plot got generated because we don't have the much difference, because the same amount of male and female and smoker and non-smoker got generated in the data. So we don't have the much difference. Here, look at here, 100, and here also we have generated 100 data points for the male and female, 100 data points for the smoker and non-smoker. So we don't have the much difference. So here, how you have to view this one is female non-smokers, these many are there. Non-smoker male, these many. Female smoker, this is the box, these many are there. So smoker and male, this is the smoker and male. Next visualization we are going to discuss is the violin plot. For displaying the violin plot, we have to install a package from ggplot package we have to install, and we have to import a library ggplot, and these are the ggplot built-in functions we are using to display a violin plot. So ggplot function, and we are defining the aesthetics here. Aesthetics x equal to group and the y equal to values, and gm violin function we are calling, and the title we are giving by using the gg title, x label by using x label, and the y label. For the x label, groups are assigned, for the y label, values got assigned. So look at here, scale fill brewer we are using, we are importing that function. The color brewer will be having the palettes regarding different colors will be there in that palette. Whichever the palette you want, you can import that one. In this case, we are taking a pastel 1 palette we are taking. This is ggplot function is very similar that we have discussed in the previous slide. So look at the visualization here, A group, B group and the C group. So we have, in this slide, we have customized the violin plot by using the functions, by deriving the palette here, by deriving a palette. So this is, and this will generate a normal violin plot, and this will generate a customized violin plot. In this visualization, we have gone through quantile plots, box and whisker plot, bubble chart, image plot, mosaic plot, violin plot. These need to be used when you have, all these plots need to be used when you have more than 100 data points and you want to do the visualization, like you want to find how many cancer patients are there, how many cancer females are there, how many cancer males are there. You want to find out that. Or you, for the real-time applications, all these will be used for the real-time applications for finding a missing value, or finding while you are doing the dimensionality reduction, while want to find out or replace a missing value. All these will be useful in the real-time examples. Thank you, one and all.